am very happy to be here, and we have an esteemed panel today to try and bring it into reality and talk a little bit more about some of the different use cases that we have going on. So the format here is I will let our panelists introduce themselves. I will ask them a few questions, but then I like it when it's a bit more interactive. We'll open it up to the audience, so please don't be shy. Raise your hand, and they'll try and get a microphone around so that people can hear you. So Sam, let's start with you.
Great. My name is Sam Bhattarai. I work at Toshiba Corporation, particularly within the digital solutions business unit. Basically, it's a big word for IoT and fog and all other system level solutions. And I've been at it for the last 5 years or so.
My name is Matt Vasey. I work inside Microsoft's IoT and AI business development organization. So I've been focused on things like fog, and the edge and moving intelligence to the edge for the last almost 4 years now. And then previous to that, I used to work in our field organization working with OEMs that built edge devices. So thank you, Rhonda, for having us.
Hi, Rhonda. My name is Eli Tiomkin. I'm with a company called NGD Systems. NGD Systems is bringing intelligence to storage. So we have an NVMe SSD with computational capabilities.
Interesting. Thank you, everybody, for the intro. Let's start out with your favorite use case. What's your favorite use case, and why does that relate to fog?
Yeah, so for Toshiba, we've been in the business of on the edge side or the front end for a long time. We've got, many of you may not know, but we've got business units that do everything from elevators to factory automation. And prior to fog taking shape and prior to the cloud, it was primarily a machine-to-machine solution. Very expensive, low bandwidth solutions that was not optimum having the things we have now. I kind of explain it like this, Rhonda. As I was coming here, I've got a 12-year-old son, and he's always inquisitive about, like most 12-year-olds, about what are you doing this time? And he knows about IoT, and he knows we've got the remote thing for opening the garage door and the Ring doorbell and stuff like that. And so I tried to explain it to him. This was happening at dinner time, so I tried to explain it to him in this perspective. Think about you have only two things. You have name your vegetable, good stuff like the edge, broccoli or spinach, whatever you want to call it, and then you have something that's essential for us, water, let's say. And you have only those two things. I asked him, son, what would you feel like if those are the only two options for you? If you're hungry and you need vitamin, you get broccoli. And if you are thirsty, you get water. And obviously, being a picky child, like most kids are, that kind of sunk in like, oh, that'd be a terrible thing. And so I told him now, what the fog is doing is really bringing you a variety of different types of food. You want Chinese food, Indian food, Mexican, Italian food. You get that variety. And depending on what you need at different times. Sometimes it might be low latency. You want a quick, snack. You can get something. You don't have to wait for the water and the vegetable to come together. If you want something that's more elaborate, maybe equate that to a complex thing that, like Flavio talked about, in terms of the industrial factory floor, where you need a complex architecture, equating that to a 3-course meal. You have that option. So to me, that kind of encompasses the whole thing about, and his his eyes lightened up when I said that, right? And so to me, that's really what fog brings to the picture. The capability to have the unique solution that provides the value, whether it be low latency, high data bandwidth, higher security, all of that coming together for the right solution at the right time, at the right place. That essentially is my kind of example use case. I'll go into, as I'm sure we will, more specific ones from an industrial perspective where I'm involved in day in and day out. But what I used to explain to my 12-year-old son, I thought was a good example to talk about what fog really provides for us, the variety, and the many choices that we have.
Yeah, great, Sam. So Microsoft is really focused on over the last several years, really building up our public cloud capability. And so when I think about the use cases in the fog that make the most sense from a Microsoft perspective, it's where we are taking the capabilities that the cloud is so good at and extending those capabilities down to the edge and to the near edge. And so the capabilities like AI or computer vision or machine learning and moving analytics and intelligence to the edge are the use cases that we see as being the most interesting. When I think about sets of use cases, I think that there are like east-west use cases and north-south. And so Microsoft has really been focused on kind of this north-south set of cases where you have public cloud providing a backplane for all of the edge devices across a breadth of geography and latency. And then you take a click stop down and you move just inside the enterprise, and you have things like Microsoft's product Azure Stack, which provides cloud capabilities just inside the enterprise's firewall. And then we go down another click stop and you have gateway devices, and they are providing smaller sets of cloud capability, and then finally right down to the edge. So when we think about things like computer vision or machine learning or AI right near the edge, those are the use cases where we see A, a lot of value for customers, and B, are uniquely suited to overcoming some of the issues where the edge computing model, which is edge devices connected up to the cloud with this great latency between them, where those use cases run into problems, the fog use cases add value and enable those scenarios to happen.
Eli?
So maybe a few words before I go into the usage cases. I want to talk briefly about NGD technology because it applies. So NGD system provide really the building blocks for the fog. If you look at the edge device, NGD system provide an NVMe SSD that is a low latency, very low weight, a high capacity, and very reliable. But on top of that, any storage devices in particular, or SSD in general, it is provide computational capabilities inside the SSDs. So by having the compute inside the SSD, you can reduce or prevent data movement. Mm-hmm. When the data arrives from the sensors to the gateway, before the data moves to the cloud, you can do the initial processing in the gateway. It doesn't need to replace the host CPU and the gateway. It augments it, and it's scalable. The more devices you add, the more capacity you have, and the more compute power you have. Now, when you take that concept and you apply it to the gateway, some of the usage cases that we see that are most beneficial are use cases where a lot of data flow from the sensors to the gateway, and that initial processing of calculation, average, bigger than, smaller than, is being done on the SSD devices. Artificial intelligence, compression, decompression, facial recognition. All these items can be done in the storage devices, and then you can flow the outcome to the cloud or back to the sensors to get usage out of that.
So you guys have done a good job of kind of painting the picture of roughly where fog could be used and how it fits into your company. Can you give us a specific example? I think I personally like to say, I like a story, right? Mm-hmm. So give me a story, just pick something that you like that resonates with you.
Yeah. Can I start?
Go ahead.
Yeah, so one of the use cases where we have fog really being implemented is one of the NAND factories, one of the largest NAND factories in the world, where we have roughly around 4,000 equipments on the factory floor, and roughly around 20,000 processes taking data from a lot of these individual machines and trying to merge them together to get the most optimum solution for the fab. And the other part of that, from a fog perspective, is the data that is coming up is a tremendous amount, in the terabytes of data per day. And so from a couple different perspectives, security, just the data upload cost perspective, it just becomes untenable to do it anywhere but in the fog layer. It's not going to be possible at the edge because there is a lot of interaction between the different machines and processes. But to get the optimum solution, it is really in that continuum right from the edge all the way up to the cloud. Now, in this particular case, there is no connectivity to the cloud, primarily because of the amount of data and the value the customer puts on that data never being exposed. But in other cases, you could have certainly metadata going to the cloud. Just in this case, it doesn't. But so having that multi-layer system or solution where you have chunks of different machines, talking to each other and communicating data so that the process optimization really happens. That's, I think, one of our big focus area. It's a big customer. Also, it used to be, at least as of last year, the biggest amount of data analytics that was done in one location. So we've been applying everything from machine learning to deep learning technologies to get maximum analytic capability out of this solution and to really optimizing the process. In the past, and here's where the really benefit comes in. In the past, it was a batch process. So we'd load the data and really look at it over the next 24 hours and try to implement that for the next day's iteration. So there was always a lag time. There was never the capability to really intercept processes that might be going out of whack and trying to fix those in process. So you'd always lose some amount of material if things went out. Now that really has been optimized. So that's one of the big really benefits in the thing. So and the other thing is now we can use deep learning, and we've really optimized the yield numbers by a significant amount, which amounts to big amounts for the factory. So those are two benefits that we got out of really implementing a fog layer where latency is optimized, storage is really looked at, and a lot of analytics can happen real time.
Great, thank you. Matt?
It's a good question, Rhonda. And one of the things I was thinking about, just as you were talking with Sam, is about use cases that sit at the intersection of digital transformation of existing processes and some of the use cases that we've been talking about in OpenFog. And so the example I like the best is work that we've done with Rolls-Royce on their jet engines. And so what ultimately they've done over a number of years is they've transformed their business from selling a capital expense engine to thinking about more of their engines as kind of propulsion as a service or thrust or power by the hour. There's all kinds of analogies for it. But what we've done with Rolls-Royce is they have taken a look at their engines and the sensor data that's coming off these engines and integrated that flow of data, which comes back into a beefy gateway, basically, that sits on top of that engine. Part of that data is downsampled and passed back through satellite connectivity, so in real time you're monitoring that engine. And then when that engine gets to the gate, that data flows to a Wi-Fi connectivity point at the gate and downloads all that data. And what they've been able to do with this solution is to understand, A, when engines are going to fail by watching the equipment in real time. B, they've been able to take a look at the assets, both people assets and parts assets across their enterprise, and be able to optimize the way they service their engines. So they know they're 100 hours away from some kind of a maintenance event, and they can know where the airplane's going to land, and by looking at integrations with their back-end systems, where there'll be a part and a mechanic capable of doing that service. And what that's been able to do is they've been able to totally transform, A, the way they service their engines, the way they monetize those engines, and also improve the SLAs that they've been able to deliver to their customers. So that's an example of fog where you have very complicated device producing huge amounts of data that needs to be acted on in near real time, but also a second set of data that is less part of the control loop and more part of transforming the back-end processes. And so that's a use case that I think resonates with a lot of customers, especially ones that have high-value assets in the field.
And as a frequent traveler, I can say I appreciate that use case of the fact that I think you rarely see delays because of engine maintenance anymore, knock wood, for all of us that have traveled here. And now it's more weather delays, so that's a better thing. Eli?
A use case that I would like to talk about is facial recognition. So one of our customers is using in their edge devices, edge gateways, they're using facial recognition. So let's take a large amount of faces that are stored in that box. The process before NGD system got engaged with the customer was, hey, there's 40 terabyte of worth of faces on this box. Now I'm inserting a new face, and I want to run it across the database to find out if that face exists or not. So the way the system worked was you take chunks and move it from storage to the memory and CPU and run that chunks over again and again and again until you complete it. And then you want to do it with a different phase. You have to run the same type of data movement over and over again. Well, NGD Systems were able to take a 2U box with 4 Catalina, 4 NVMe devices, and run a weightless neural network that is running on the drive, and you're able to train each drive with every face that you want to compare the data set. You train the drives, and then you run the search. The outcome of before and after was that the search is running much faster than the old system, and you save a lot of power. The host CPU consumes a lot of power, and that's a major benefit that we bring to the table. So,
Interesting. Yeah, and you're not wasting the movement.
the data doesn't move. The data stays where it is.
Which industries do you see moving ahead the fastest as it relates to fog? I mean, we've heard a lot about some of the different verticals. Christian gave us a good example. Fabio just talked quite a bit about the industrial use case. What do you see in your, from your perspective of where you see fog taking off the quickest?
Yeah, I've got a little bit of a myopic view perspective on that because I'm so focused on the quote-unquote industrial space, which is basically manufacturing, transportation, energy. Those all seem very much, it's a long cycle, but they're also moving very rapidly. It was interesting to see what Christian showed us. From our perspective, we see manufacturing really moving forward very fast, very actively. But I think that's my perspective. I'll let others that have a broader perspective talk to it.
I have to agree. I mean, the industrial space pencils out very quickly. And so when you take a look at the investment that you're going to make in fog, it's very easy to kind of come up with an ROI and say, well, this pays off in a couple of years. But when you look at things like smart city, that the value is harder to quantify when you say, well, how do I improve the value of a city to a citizen, and how do I improve the return on a tax dollar? But I believe that smart city is going to be one of these areas that is linked to things like autonomous driving, having intelligent substrate for a car or a vehicle to travel through. I think that's another area that's going to grow very nicely and also deliver a ton of value. I think the trick will be, how do you measure the value on the return to a taxpayer on improved infrastructure? And certainly in this country, it's difficult to justify that. In other parts of the world, we're starting to see that some of those ROIs proving out.
Embedded artificial intelligence is the market that I see picking up tremendously. And then the autonomous car, maybe in the longer term, and not only for data that is being stored and captured by the car, but the entire ecosystem of car communicating with other cars as well.
Yeah, and one thing to add, as Christian was talking about it this morning, I was thinking about the fact that we have fog in a very horizontal fashion. The benefit of fog really taking off would be seen by when the analysts have difficulty kind of putting ROI or revenue in any particular bucket, where the fog node that's at the crossroads is serving the smart city, serving transportation applications, and really makes it difficult to really slice up. I think that is really would be one indicator to me anyway that would say that fog is really taking hold.
That's a great point. Thank you. So what do you guys see as some of the challenges in fog being implemented? Where do you see, as your companies are deploying these things, where are the hangups? What are the problems that you were currently seeing that need to be worked out?
Yeah. Culture, I think, is big one. And we used to talk about this, in IoT for a long time, that no one company, no matter how big a company there are, you can, I'm sure Matt will talk about the same thing. We talk about the same way. We've got many divisions that work on many different verticals, but we don't have the capability, far from it, to provide a full solution. So working as an ecosystem with partners collaboratively, the culture is certainly, we have to be more concerned about. A lot of us are coming from the IT mindset, and how that applies, and there's no 3-year turnover in the OT segment when we've got to deal with equipment, and I've encountered this where we see equipment in the factory floor that are 30, 40 years old, and they plan on keeping it for under 20 years. And so dealing with that type of scenario, how are you going to support that? And what is really the solution you're going to provide to the customers that makes sense to them? Not what makes sense to us from our historical path, but what makes sense to them. I think those are the primary gaps or hurdles that we have to cross over. And then those are all technological or cultural. Then the other part is the business part. Flavio talked about it a little bit about how do you get the share the revenue. It's not a piecemeal thing saying here's $1,000 worth of equipment for you when that thing is providing a lot more value to the customer. How do you really make it equitable? How do you make it? So that's another, I think, path that we have to yet to go through. There's been some innovative ways of people working that solution, and I think a lot of openness and a lot of willingness to work together really comes into the picture. So those are all, I think, things that we've got to work through collectively.
Yeah, it's when you think about kind of what the barriers to adoption and what the barriers to success are. I think about where we are from a maturity perspective in the market. So today we are pretty early, both in IoT and in the fog. And so a lot of the concerns that we're trying to solve for are things like connectivity. And so I have a series of labs. I have three. I have a lab in Shenzhen, a lab in Redmond, and a lab in Munich. And we bring customers in, and they, half of them are probably enterprise customers. They're like trying to connect some device that is central to their business and derive some kind of insight from it. And then the other half are startups. And 201, their first concern is figuring the connectivity out and figuring out how you provide the right level of connectivity and the right latency and the right cost. And I think that question or that barrier is representative of us being so early. As we mature into the market a little bit more, I think security is going to become the real issue. When we talk to OEMs, folks that are building machines about security, there are lots of kind of hard, how do you authenticate a device? How do you validate that the device is in fact the device you think it is? And it's kind of solving for all these security problems. And you propose some solutions. The OEM typically says, well, that's a $4 part. I can't put a $4 part to manage security into my device. And it's a $1,000 thing. It's a refrigerator or something. Today, because everyone's focused on connectivity, we're making this trade-off to make it easy to connect. I think as we move up this kind of maturity curve, we're going to realize, wow, we have short-circuited security in order for to make connectivity easy, and I think security has become the big barrier, and we're going to kind of hit the wall in a couple of years, both on the consumer side and on the enterprise side. And I think the enterprise side is going to be more painful when it happens. And the consumer side, we've all probably familiar with what's happened with Equifax and all of our personal data, if you live in the United States, is very possibly been compromised. When our refrigerator starts passing out information about our personal lives, I think this was going to be a big issue. And when our industrial equipment decides it's going to stop working until you pay a ransom, that's going to be even a faster thing. So I think security is just this huge barrier. And right now, there are some good solutions, but we need to change the culture, to your point, Sam, about security and valuing security and kind of future-proofing the Internet of Things that we're building today by investing in security.
Great point. Thank you.
So I have to agree with my colleague that security is one of the top items that it is a concern about IoT and how the industry is planning to adopt solutions around security. Another item is the actual Open Fog Consortium. I think it's a great beginning to start and standardize around the solutions. And right, when we say open fog, it is the network, it is the security, it is the storage. I think it's everything together, and then the ability of the industry to adopt that as standards for the ecosystem, for the benefits of all.
Great, thank you. Okay, I think we'll take a break here and see if there are any questions from the audience. If there's anything, oh, we have a question over here. Fantastic. Hang on, Evan's coming with a microphone.
Kishore Ramachandran, Georgia Tech. Flavio's talk, he mentioned that, there's this IT-OT convergence that should be at the core of fog evolution. And you know, all of the panelists gave excellent examples of fog computing applications in their specific domain. But I'm just curious, I mean, none of them sort of hit that IT-OT convergence as much. I mean, most of them were sort of gateways or maybe partially moving something from the cloud to the edge or something like that. But the question is, are we too far away from that kind of convergence? And where do you think it's moving, and how we will see that in sort of use cases in the future?
When I think about IT and OT convergence, there's a couple of things. One is this whole brownfield versus greenfield scenario. In greenfields, it's a lot easier from a device perspective to kind of start that convergence. But the real challenge is the integration with back-end systems. And when you think about the cycle of innovation, how do you change the way that we design, test, manufacture, and then operate both industrial equipment, but also the things that we're building? And so until we start seeing those integrations adding value, OT convergence is going to be stuck in the kind of brownfield world where it is today, where the highest level thing in the enterprise is a historian, and maybe somebody comes and yanks a drive out and goes away someplace and does some analysis to figure out what's going on, but it is really not an integrated solution where it's feeding back into SAP and rolling a truck because something is happening on a sensor that AI is determined is going to cause a bearing to heat up. We're not seeing that level of convergence in most enterprises today, but I mean, I think that's where that's going to happen, is back-end integrations. I don't know. What do you think?
Yeah, I think I agree completely. So in terms of the area that we focus on, I'd say 95% of where we are engaged with is in the brownfield space. So in that, like Matt mentioned, it's hard to architect things. So things we do are make it more easier to have integrations. Things like data diode. So data is going one way and not able to go impact the OT. Those type of capabilities are, I think, slowly going to have the convergence, but it's very gradual, as you mentioned. And in the greenfield, it's a much better opportunity to start from the ground up fresh. But since most of the capability that we deal with today are brownfield for most companies, I think, in the industrial sector, it's more of a gradual step up.
But Sam, it sounded like the example you gave us of the semiconductor manufacturing of the memory chips, of moving away from the batch processing. You had to overcome the IT-OT barrier, right? Because you were real-time monitoring what was happening, so that you must have sold the efficiency of what the OT people were going to get. Can you tell us a bit more about that?
Yeah, those are a little more specific use cases, I would say, where OT is the primary dominant factor, and IT is servicing the things around it. So it's easier to impact the solution when there's one driver. I think the bigger problem is when you have OT down and then IT at the top, or not saying that's how the order goes, but when there's distinct separation between OT and IT is where we have more issues in terms of having the convergence not yet be achievable.
Is there another question?
Yeah, I have a question here. I'm Tom Karpwitz from IBM. You mentioned specifically with industrial the fact that we've got all this, if you will, legacy equipment which needs to be supported. Absolutely, no doubt. In any of the other sort of sectors or verticals where you think you're going to get a relatively immediate bang for the buck with fog, are there areas where it's primarily we're going to ignore what's in place already and just go after brand new stuff?
One area where we're seeing that is in the developing world, where a lot of technologies get jumped, and so you don't end up having to build lay out wire networks. And so we're seeing this kind of move to wireless in Africa and places where you can or places where there's been kind of significant disasters. You jump over those technologies and you get to you get all new infrastructure. So we're seeing that in some geographies where things are moving more quickly. I think also in new verticals like the autonomous driving, for instance, is an area where we're just jumping right to all the newest technologies. So that's a couple of areas.
Yep. Yeah, exactly. Autonomous vehicle is where we're seeing that also in terms of the infrastructure that's going into place. and I think new geographies jumping over. I completely agree.
Yeah, I agree. So I think that overall, the majority of the IoT implementation and fog implementation are leaning towards new technologies and new implementation, new infrastructure.
So we've not talked about retail at all, and that seems to be an area, and maybe I'm just not informed about retail, but that seems to be an area where we really haven't done much with technology. And granted, measuring customer satisfaction is difficult unless you measure it in repeat sales, right? But is that an area where maybe we could utilize new technology and fog to get some more loyalty? Well, you're at least nodding your head, so thank you. You guys have any insight on that?
Yeah, well, I know that, like things like Beacon and all of that stuff are being used a lot in retail. Toshiba, we have a POS, point of sale application that's pretty pervasive, and we're certainly using a fog type of architecture where you take in information from the beacons and the Bluetooth devices that are spread all over, and take that in and merge that in with more customer specific data about what type of buying patterns and all of that stuff. So those are certainly being used. So that's a convergence of the cloud data, analytics, buying habits and all of that stuff. But beyond that, I don't know a whole lot more.
So video analytics, I think, is being applied into some of the retail space. I've seen a few applications where because you have now video in all the retail spaces, or most of them, you start seeing analytics on heat maps. Where is the customer going into the store, where are they spending most of the time, and you're able to change the layout of the retail store to be more appealing.
Yeah, another one talking about retail is we have the capability in Toshiba to do a lot of facial recognition, and we're employing those type of things both for security at airports, to be able to evaluate crowds, as well as in retail space, like Ella mentioned about a particular area or people coming in, how to send the right salespeople to the right location if there's a lot of people, those type of things.
One of the interesting things about retail is that it's just under such intense pressure to transform or die that they are able to make bets on technology that you wouldn't otherwise make. And so with that kind of backdrop, we think there's a lot of opportunity both to kind of redefine what omni-channel means, and you see some of the retailers doing this where they're actually looking to transform the supply or logistics ability where you can go in, use a store as a, kind of a trial area. And in order to do that, you need to have good people tracking, which can be leveraged, through like network technologies or watching phones or beacons, and then also supply chain optimization. So understanding like what people are handling, what they're moving around in the store, what's leaving the store, and so that you can more effectively with less product on the shelf, kind of optimize the retail outlet. I'll say that there's a lot of momentum for all these guys to make changes, but what the right changes are not obviously clear.
Yeah.
And there's so much pressure that every time our friends, the other big cloud provider in the Seattle area, makes any kind of noise about entering a space, everybody gets really excited, and I think that dynamic is going to continue for a number of years.
Interesting. We have another question.
Yija from Huawei. So I heard about people talk about security, and it's a very critical issue, and also be one of the most challenges for IoT and fog. But I haven't heard about the privacy. So especially for the consumer side, probably privacy is the number one issue, because eventually end users' confidence may determine whether the IoT or fog can be successful. So also you look at privacy, that probably will be talked about the government. Different region probably have a different practice on that, and also the regulatory issue. Is the panel can comment on that?
So I would start. Yeah, so privacy and security go hand in hand together, and I do see it as a big items for the fog. I know that NGD System is involved with a customer that tries to implement encryption and authentication per user on their infrastructure. And the current network just does not support it. So we're trying to implement it inside the drive. So inside the drive, you're going to actually assign the encryption key and authentication per instant on a large scale. So it's on their mind. I know a lot of customers are looking into it, how they solve that privacy issue. It's not the content sometimes that goes in the network. It is the information about who's using it, what they're doing it, how much they're doing it. That's what company is trying to protect to make sure that the consumers feel safe.
You know, the work that the Online Trust Alliance has done over the last 20 years, really about helping users define kind of what their private data is and what they should be able to dictate to people who hold their data, how they can dictate how that data is handled, what is shared. And so, I mean, I think that, and that's a group that I'm somewhat involved with, is not affiliated with OpenFog, but I think some of the work that like Online Trust Alliance has done with regards to personal data, and then some of the work that you see certainly around data sovereignty in EMEA or Europe, you know, those things are developing now, and I think now with you know, FOG being able to move the data center capability down to either a geography or even a microgeography to manage that data, that coupled with having, you know, really strong guidelines about what you can and cannot do with personal data will solve some of these problems. But I think there's lots of work to do there.
Yeah, I agree with both what Eli and Matt said. I'll just use a use case that we're working with the University of California in Irvine, where we're building a use case where they're monitoring all the participants that go into a university building that has a lot of beacons. And if you opt in, you have the, so it's a trade-off. What they've done is if you opt in with your privacy information, you can put in the temperature that you'd like a particular room to be in. And if it'll kind of canvas all the people that are in the room and try to optimize the temperature in that particular room for that person's or for the majority's use case. So that's a one way where, but that data is not shared with anybody else. So it's only shared to come up with the thing. And there's many layers they've thought through in terms of privacy, all the way from do you want your professor to know, if you're a student, to know what time you're coming into the building? Are you spending 12 hours a day there? Maybe that'll give you a brownie point from the professor. So those type of things they're trying out. So I think privacy is a big part of this. The fact that you can localize data with FOG certainly gives you that capability to make it either from a geography perspective or from a technology perspective, certainly enables FOG, or sorry, the privacy part, which is the other aspect of security.
Yeah, and just to echo what they said, I think one of the things we're seeing is the regulation in Europe is much stricter than it is here or anywhere else that we've seen, and I think that's is guiding our thinking toward starting to think more seriously about it earlier, because we know those regulations are there, are going to come about, and nobody wants to get sued. Thank you. I think there was another question back here. Yeah.
Merrill Herman, Schneider Electric. So a question for Sam. Given that you're deploying below the IT/OT line, and we are bringing traditionally IT technology into an OT space, how do you manage the fact that you've got this guy that his only notion of virtualization is from watching the movie The Matrix? So how do you manage the maintenance and management aspect of your deployments with this technology or the talent pool that you've got?
Yeah, it's a ongoing issue right now. So it's not a solved solution. Obviously, there's many innovative companies coming up with options about how to do that. You heard some of it earlier today also in terms of, Flavio had some talks about how he's got a proposal about how to manage the legacy stuff by virtualizing the Windows type of thing. So there's opportunities like that are coming up. I think it's really a area that's still looking for a complete solution. It's what we're moving towards is a gradual improvement in terms of what we can do, but it's not a foregone conclusion by now.
One of the ways that we've been, trying to solve this problem, and it's a super big problem, is using augmented reality. And so in a lot of cases, you'll have an intelligent set of eyes 1,000 miles away, and by putting a HoloLens or an augmented reality device on the technician you have on site, and taking that technician basically takes those skilled eyes that are 2,000 miles away to the machine, access their hands in that space, and can be walked through a diagnostic procedure. Those sorts of scenarios can quicken reduce the time it takes to diagnose the problem, identify specifically which part or group of parts has failed, and then when you roll the truck one time with the part and the technician that can do the work, or better, you just ship the part and the less skilled technician is able to do the work being aided using augmented reality as a training device. So that's another way to solve the problem.
Yeah, one of the other areas we're also using, it's not completely a solution that's implemented yet in the field, but using a lot of AI, using historical data and trying to make some automated assistance to the technician or the user is also another area. I think it's bearing fruit. The value is coming up very strongly, but not quite prioritized in the broader sense yet.
Thank you.
Question here this is Fenji from Western Digital. I have a question on competition and market power. So you see a lot of your customers, OT customers, they don't talk in IT language. So, but we know that a lot of entrenched OT players like GE, Siemens, they really understand the customers really well. And what do you see there? And they massively invest in AI as well. The technology actually nothing new to them. They try to integrate from the bottom up and to move up the pyramid we saw and to address those challenges. So do you see them as longer term competitors since they have the market power, they have the customer engagement, and they also have the system integrator experience?
It's a good question. Who wants to take that?
From our perspective, from a Microsoft perspective, we look at all of the players in the marketplace as partners that can leverage our cloud assets and some of the assets that we push down into the enterprise to make their machines better, to make their machines more intelligent. And so we mostly see those partners long term. GE you mentioned, and we announced a deal this week with General Electric to do a wide variety of things with GE bits running on Microsoft's cloud and delivering value to customers together. I think that those sorts of deals are going to be transformational from a customer perspective, seeing two industry players working together and delivering a lot more value together, and I think that's where the market's going.
So as someone from Western Digital, and we have Toshiba here, and I'm from NGD Systems, all do storage, I don't think we have to look at these companies as competitors. They're looking to get the storage technology. We do intelligent storage. Toshiba has a very wide line of storage product. They look to get that and integrate it into their solutions and add it and offer that to their customers. So they're not going to start making CPUs and storage and write the software that will compete in other spaces.
Well, and creating clouds, right, to be inclusive of Matt. Yep. Okay, I think we can take one more because don't call me late for lunch.
Hi, I have a question for you. I've heard with the industrial Internet of Things, I've heard 30,000 sensors on this thing, 4,000 sensors on that. And then I've also heard, streaming video. So I'm kind of trying to get a feel for, is the driver here the numbers of sensors with lower data rates, or is it more of a few sensors that are putting out a lot of data rate? How are we getting these big volumes?
Yeah, I think it depends on the use case. It's a variety of all of those things. There are some cases where the data flow is very, very strong, so it may be a few sensors, like the factories I was talking about. Some of those machines are generating lots of data. Maybe a few sensors per machine, but lots of data coming through each time. And in other cases, when you look at broader application in general, maybe more distributed, I think it could be a lot of small sensors. So I think it really varies on the thing and the use case and the application. That's at least what I see from my perspective.
Yeah, I see the same thing. It really depends on the application. You see a lot of variety, but from my perspective, from a storage perspective, the trend is more and more data is flowing from the sensors. And it doesn't matter if it's a few sensors with a lot of data or multiple sensors with very limited amount of data. The data is growing tremendously, and that's the challenge that we're trying to optimize for.
Yeah, I think there's like this kind of explosion of sensors in devices. And an example that comes to mind is a few weeks ago I had an OEM come in and they had a very large lithium cell battery with like 300 or 400 sensors spread throughout this battery. And we leveraged kind of machine learning and some kind of data science tools to take a look at all the data that's been streaming off this device and discovered that the large battery was either hot or it was cold. and the reason there's so many sensors is because we don't necessarily understand our machines as well as we could, because we haven't thought about how do we sensorize a device like a battery, for instance. And I think that as our understanding of machine learning and of our machines grows, we'll be able to get the right sensors in the right places and start kind of optimizing the flow of data. But today, I think that there is a sense that more data is good and less data is bad. And the reality is getting the right data is the key thing. And so as we develop understanding and we democratize data science in the engineering process, we'll end up getting more meaningful data from less sensors. I think that's where we end up. But I think in the near term, we're going to be faced with a lot of data off a lot of sensors. And when you actually take a look at all those data sets, a lot of them are featureless, meaning they don't actually give you any insight. They just determine that thing that I said is hot or it's cold. So.
Yeah, a lot of data, and you need to screen it to get the essential data out of that big data chunk.
Yeah.
Well, thank you very much. I appreciate you guys taking the time and sharing your insights with you, and thank you to the audience. I think all of us will be around for the next few days, so if you have further questions, feel free to grab us at a networking session. So,
Yeah.
thank you.
Thank you, Rhonda.